Hello friends, the today topic is oscillator. Here we are talking about oscillator. Here you see a pictorial diagram of oscillator. This is amplifier, this is a speaker, and this is feedback network. First of all, I will introduce to basic meaning of the oscillator. What is oscillator? Oscillator is nothing, simply a circuit which is used to generate the waveform as per our requirement. It can be also used in the designing of waveform generator. Okay, here we apply no any input, but still we get output at the speaker. So basically this is a unique feature of oscillator. Okay, here you can see that this is the oscillator circuit, and we apply a simple BCC signal, that is a DC source, and no any input signal, but still we get output. This is the basic advantage of oscillator. So apart from this, here is a circuit, amplifier and feedback, and these two will combine and give a total phase shift of 360 at the between the input and output. Okay, but let us talk about a different aspects of oscillator. Okay, it can also be called amplifier because it amplifies the signal. Okay, but here question is arise, what is amplifier and what is oscillator? Sorry, the question is arise, is there any difference between amplifier and oscillator? Yeah, definitely there is a lot of difference between amplifier and oscillator. First of all, in amplifier, suppose here I assume this is an oscillator circuit. If you does not give an input, you get output at the output side. Okay, and this is the output. Okay, but in case of amplifier, suppose I replace this circuit in amplifier and we apply just a BI signal, that is input AC signal, then we get output signals. So basically for amplifier we need input and get output, but for oscillator we does not get any input, just we give BCC and we get output. Okay, so amplifier and oscillator both are different terms, and the main difference of that is the amplifier and oscillator. Okay, if we talk about the gain terms, the gain of amplifier is very much finite, but in case of oscillator, here you saw that gain is infinite due to L and C elements. Here, okay, amplifier we apply negative feedback, but in case of oscillator we apply positive feedback. And the next one is the stability. The stability of amplifier is very much high, but in case of oscillation it is very much less, because the energy continues being oscillated due to capacitor and inductor. Okay, so this is the basic difference between amplifier and oscillator. Okay, but how can we decide any circuit is amplifier and oscillator? So a famous scientist, Barkhausen, who just give the condition of oscillator, he says that we can see any circuit as an oscillator if the gain means amplifier gain and feedback gain equal to 1. It means the product of these two factor will 1. That is the first conditions, and next condition is the phase difference between input and output due to the this element plus this element will total give equal to 360. This is the most desirable condition of oscillator. Okay, you can always know that the gain of oscillator is always equal to 1. Yeah, it is true, and many books write it, but in actual oscillator the gain AB is always greater than unity, so that external loss will be minimized. So that is the basic overview of oscillator and amplifier. Oscillator can be further classified into two types. Okay, audio frequency and RF oscillator. Audio frequency, the range of frequency that we heard in our daily life, it is from 20 hertz to 20 kilohertz. Okay, and this is RF oscillator. Okay, here the frequency is greater than 20 hertz. AF means audio frequency and RF means radio frequency amplifier. Okay, and further audio frequency amplifier will classified as two types. Here is RC phase oscillator, it means resistance and capacitor, and next is Wien bridge oscillator. Okay, and RC phase shift oscillator can be also made by op-amp, FET and BJT. Okay, so RC phase oscillator is called fixed frequency oscillator. Means if you want to use RC phase oscillator, then it gives fixed oscillation. But in case of Wien bridge oscillator, it is variable frequency. The frequency of oscillation will always vary due to balance breeze. Okay, next RF oscillator, and here that is the type of RF oscillator. First is Hartley, Colpit, Clap, crystal oscillator, and in all discussion you just get the point of oscillator. But here a question arises, what is the practical use of, how can we visualize oscillator in real life? Here suppose this is a watch, this is an alarm watch. Okay, and in the back side here a battery is attached in circuit. If you open this circuit of watch, then you found a quartz crystal. A quartz crystal will include in this circuit, and that quartz crystal is called also a crystal oscillator, and that